Okay, go. You're good.
Time out?
No, you're good. Go.
Time out. Let's put this to good work here. Here's my next problem, h of x. 3x to the 5th plus 2x to the 4th minus 3x minus 2. And I want to know who in this room feels lucky today. Lucky in mathematics. My p-value over my q-value. We're going to write them out. What's my p? Plus or minus 2, plus or minus 1. Thank you. What's my q? Plus or minus 3, plus or minus 1, right? So let's write out the list of doing all the possibilities. I kind of wrote these backwards than I did before, but who cares? Let's start with the 1. Plus or minus 1 over plus or minus 1 is plus or minus 1. Plus or minus 1 over plus or minus 3 is plus or minus 1/3. Plus or minus 2 over plus or minus 1 is plus or minus 2. And plus or minus 2 over plus or minus 3 is plus or minus 2/3. There's my list. Now, who in here thinks they could go buy a scratch-off lottery ticket and win? Who in here thinks that they are lucky today? Okay? Mr. Salter, pick one. Anyone you want. There's 8 of them. I don't care.
-1/3.
Negative what?
1/3.
Negative 1/3. We're going to put that right here. Okay? We're going to put this inside a little box. What do we put inside a little box for?
2.
How do we know if negative 1/3 is correct? How do I know if negative 1/3 is a root of that polynomial? You synthetic divide, and what? What happens? If you get no remainder, right, you win. You win the game. If you get a remainder, you lost. Here we go. My leading coefficient is 3, then 2, then 0. There's a cube, there's a squared, there's a linear, and there's my constant. Here we go. I want to see if you're right. First number, drop it. Multiply around. Negative 1/3 times 3 is negative 1. You probably sometimes, if you're wrong, you're not going to have to go all the way through this thing because it's going to get ridiculous. Okay? Add them up is 1. Multiply. Negative 1/3 times, whoops. Add them up is 1. Negative 1/3 times 1 is negative 1/3. Add them up is negative 1/3. Negative 1/3 times negative 1/3 is positive 1/9. Is this going to work?
No.
Add them up is 1/9. Negative 1/3 times, this is negative 1/27. I think you are wrong. So I cross this one out.
Positive.
Try
Mr. Williams, you feel lucky. Give me a number.
2.
2. Let's try 2. 3, 2, 0, 0, negative 3, negative 2. Okay? First number, drop, is 3. 2 times 3 is 6. Add them up is 8. 2 times 8 is 16. Add them up is 16. 2 times 16 is 32. When the numbers start to get ultimately larger and larger, there's probably not any way of coming back to it. 2 times 32 is 64. I don't think this is going to work.
What negative?
Doesn't mean I'm wrong.
Stogner, let's try negative.
Just guess.
3, 2, 0, 0, negative 3, negative 2.
-1.
First number, drop. I'm feeling good about this. Let's see. Negative 2 times negative 3 is negative 6. Add them up is negative 4. Negative 2 and negative 4 is 8. Add them up is 8. Negative 2 and 8 is negative 16. Add them up as negative 16. Not looking good, Stogners. 29, 58, 56. Not going to work as a remainder. You. 1. Let's try positive 1. Positive 1 is usually a good place to start. 3, 2, 0, 0, negative 3, negative 2. Jacobs feels lucky. 3, drop it. 1 times 3 is 3, add them up is 5. 1 times 5 is 5, add them up is 5. 1 times 5 is 5, add them up is 5. 1 times 5 is 5, add them up is 2. 1 times 2 is 2, and I have no remainder. You win. Now,
Congratulations, you don't die.
how many solutions are we looking for? 5. We don't know how many are real, we don't know how many are non-real, but we can check again with what we have left over. Alright? These are the ones that are not good. We can start with what we have left over because they have no remainder. Wager, which one you want to try?
2/3.
2/3?
Negative.
Wager, what do you want to try? Negative. Let's try negative.
How many are we supposed to have?
There's 5 total. But we don't know what are real and what are not real. I'm just checking the irrational and the rational ones.
We're going to have a negative. What? What do you mean?
I don't know. Here we go. 3 drops down. Negative 1 times 3 is negative 3. Add them up as 2. Negative 1 times 2 is negative 2. Add them up as 3. Negative 1 times 3 is negative 3. Add them up as 2. Looking good. Negative 1 times 2 is negative 2. Wager, you win.
So if they have a remainder, they're imaginary?
I'm sorry?
They have a remainder, they're imaginary?
If they have a remainder, then that number is not a root of the polynomial.
If you use negative 1 on like the top one, it didn't work.
No, it would. Try it again. You made a mistake. Okay. I've tried negative 1/3 and 2 and negative 2, and these both work. I think I have one more here.
How many times
Positive and negative.
Until you're done. Until you found them all.
positive?
Let's try 2/3. Now I can plug this into what I have left over, right? Which is 3, 2, 3, 2. And this looks good here. 3, drop it. 2/3 times 3 is 2. Can we try negative 2/3 instead? 2/3 times 3. Negative 2/3 times 3 is negative 2. That's a 0. Negative 2/3 times 0 is 0. Add them up is 3. Negative 2/3 times 3 is negative 2. And I have no remainder. Q, you win. So I have 3 so far. Now, can I just go by what I have left? Listen to me. I synthetic divided from a 5th degree polynomial, and I was left with a 4th degree polynomial. I synthetic divided again, and I was left with a 3rd degree polynomial. I synthetic divided again, and I'm left with a 2nd degree polynomial, or a squared. This is 3x squared plus 0x plus 3. That's what it means. Or 3x squared plus 3. This is the remaining factor. Let's set this thing equal to 0 and find them. You ready? Minus 3 from both sides. And it is 3x squared equals negative 3. Right? And I divide by 3 on both sides. Negative 3 divided by 3 is negative 1. And when I take the square root, what are my other two roots? Plus or minus I.
Oh my God.
So I have 5 roots because I have a 5th degree polynomial.
I thought they had to be one of those.
Okay, what?
I thought they had to be from the lens.
The rational real ones do, but I, Shaft, is not on my list because it's not real.
So we have to go through all those numbers on the list?
Until you found them all, until you're done.
How do
Now.
you know when to do that?
Let me give you a little trick here. This right here is completely obnoxious. Okay? This is really time-consuming and time-wasting. Okay? You, listen to me very closely. You thought you knew for sure what 2 of them would be. And I'm going to guess that you looked on the calculator, and that's okay. Fine, fine. I'm going to guess that you thought about what it might be by looking on the calculator. You can estimate. If I were to graph this thing, okay, if you were to type in the calculator, I got a root at 1, and a root at negative 1, and a root at negative 2/3, and plus or minus I. So as a 5th degree, it would be 1, 2, 3, 4, 5, something like that. I can look on here, okay, it looks like that one of my roots is at positive 1. Let me try it just to make sure. So you can be guided by the calculator. I'm okay with that. All right?
How do you get imaginary numbers like in calculus?
Uh-huh.
You
You don't. You got to find them using synthetic division.
don't. So you have to do it anyway.
Yes, but you don't have to try the ones by guessing to see who feels lucky. That was just to have fun.
That was not funny.
Okay?
Like, for who? You wait. How do you find it again?
What you might want to do, okay, what we might want to do here, Wager, listen to me. You take the original polynomial and type it in. And then you can look on the graph and just see, where does it look like it crosses my axis? And if it looks like it crosses at 1, try it and it should work. Now, it might not all the time, because what if it was 1.1? It just looks like 1 on the calculator. You got to try it, see if you have no remainder. It looks like negative 1, it crosses the axis. Try it, see if you have no remainder. And keep breaking it down further and further until you got all 5. So finally, I have a list of all my roots. They are plus or minus 1.
Excuse me, staff and students, Ms. Shaw's fourth hour will be meeting in her classroom today. Again, Ms. Shaw's fourth hour will be meeting in her classroom.
Plus or minus 1. I got plus or minus I, and I also have negative
How do
2/3.
you know when to look for the imaginary one?
Because what you have left here, I factored it, said equal to 0, and I was left with I.
If you
What
get,
you really have, like, until you get to x squared.
so just
Yeah, when I'm down to x squared, I know that I can factor it or solve it. Especially with a 0 here, that was real nice. We'll do more tomorrow. Let me give you a few problems to look at here, okay? We're good here, sir. Let's YouTube.